Welcome, ladies and gentlemen. Here is our first lecture of this unit. And where is my, come on, pen. Yeah, here we go. There we go. Oh, let's go with magenta or purple. So we're looking at the periodic table. What is the periodic table and why do we use it? So basically what we scientists do is look to try and create order from the chaos. This helps us try and figure out things that happen with nature, how everything works, and we're trying to organize it. And then as we organize things, we find things that don't match or don't really fit where it is, and we figure out why. And so the current form of the periodic table was made by this Russian Mendeleev about in the 1800s, and he decided to develop a table, a list of elements in order of its atomic mass and reactivity. So this is what he did. He kind of lined them up, and then he kind of grouped them together, and then he lined them within the groups. And we were working with what we call salts, which is basically a metal, and we'll get to these definitions in a minute, and a non-metal. So we're looking at these type of salts, like sodium chloride, calcium chloride, stuff like that, and they have put them into all these rows and columns. And then we realized some of the elements didn't fit. And so this gentleman named Moseley, he is I believe he was a New Zealander, suggested using atomic number instead of mass, because he was doing some X-ray studies, and the X-rays actually for each element had a particular atomic mass number. They're all kind of repetitive after a number. We now know the atomic number is actually a number of protons. Now, why don't we just say number of protons? Well, the thing is that atomic number became into being in about the 1910, 1911, back when we were looking at protons, and it just kind of made sense when we didn't realize how they went together until the 1920s and 1930s. And by that time, we're still using atomic number. So let's take a look at the current periodic table. And we have these periodic tables. Here it is. We got the families or columns. They're called families. And then we have the rows. Now you notice that we have a key. I'm going to put the key down here. This is the symbol. And then we have the name. And then we have the average atomic mass. Then up here was the atomic number up in the corner. Now each periodic table should have a key or a description of what all these symbols mean. Some are more complicated than others. So this is our periodic table. And I am going to draw a line along this part of the periodic table. And I'll reiterate this in a minute, but these are the metals. Everything from the left of this line to the right of the line is non-metals. And in between, and on the line, we call them metalloids or semi-metals, because these elements here can act as both metals and non-metals. And this is what gives, again, working with chemistry very interesting. This is what makes us explore what's going on and make us new elements, new compounds, and so on and so forth. So just to reiterate, we've got the left side is metals, right-hand side non-metals, and the elements along the bold line is metalloids. And I'm going to skip this one. This is basically a repeat because I've been doing this a little bit because I want to say something. Metals, here are the characteristics of metals. So shiny. That's the thing is, they're going to be shiny. Malleable means you can hit it and they bend. Ductile, they can be twisted. All of them are solids except for mercury. And all of them conduct heat and electricity. So they're very good at conducting heat and electricity. Non-metals, they're brittle. A little bit of force and they break. They do not conduct electricity and not much heat either. So they're actually great insulators. Very colorful. They exist as gases, mostly some are gases, sometimes liquids, sometimes solid. And again, we're going to iterate. Metalloids have both properties of metals and non-metals. So if we take a look at this periodic table, here's mercury. It is a liquid. Bromine is a liquid. Iodine is a solid. So this is a solid. This is a liquid. This is a liquid. Now, gases, and sometimes the periodic table color codes them. So some periodic tables will be color coded for metals, non-metals, gases, liquids, and solids. Gallium has a boiling point about room temperature, your body temperature, so you can melt it in your hand. Iodine is actually one of the few non-metals that, when in a crystal form, it's a little shiny, but it is brittle. So we know it's a non-metal. So it's all, and purple, brown, green. So all these have different colors. And we'll talk about more chemistry and the colors involved in chemistry as we do more reactions. And you notice that I'm going to switch gears a little bit. You notice up here we have three numbers. We've got 1, 1A, and that's a Roman numeral 1. And then we've got a Arabic number 1. And what they're doing is actually describe the health of the families. And there are two ways to describe this. And the column of the labels is, we're talking about 1 through 18 is new terminology. That's the newest way we do things. Here in the States, we still like to go 1A, 2A, especially in teaching, because that actually tells us number of valence electrons or reactive electrons. In the atom. And we're going to say the valence electrons are the electron in the highest energy level. And we're going to stress more on this in chapter 4. So we're going to talk more about this in chapter 4. And in chapter 6, 7, 8, 9, and so on. Now, I'm going to go back a minute. We got column names. So these are the common names for all these columns. So I'm going to come back here, and this is column 1 is called alkali metals. And this is alkali earth. Alkali means making base. Now I want to point out with hydrogen, sometimes hydrogen can be over here on the left, right above fluorine, because hydrogen is one of those few elements that are distinctly have different chemistries than the rest of the family they belong to. Hydrogen can act as a metal or non-metal. It is very reactive, and it's a gas. And sometimes you see it both here and here on periodic tables. This group is transition metals. because they transition from the metals to the nonmetals, and realize the metals actually come over here to the line. So I'll draw this line again. They're the metalloids, and as we go to the right, more and more they become more like nonmetals. And here are my nonmetals, and this is, we'll start here, this is noble gases. Noble gases. Here are the halogens. Chalcogens or chalk picogens, and I want to point out this column here in the transition metals. Copper, silver, gold are all used for coins, so they're called coinage metals. Copper, silver, gold were all used for money, and sometimes copper still do, silver still do. And here are the proper names and the spellings of each, because you know me, I probably misspell a lot of things lately. Now we're going to talk about rows. The rows are basically the energy levels of the orbitals. We'll talk about this more in chapter 4, but I want to introduce it now. Highest energy levels, transition metals is the d orbitals, but it's one level back. And the lactinide and actinide series, I'm going to go back to this. These two should be up here, but they're actually here, and this is due to electron configuration. We'll talk more about that in chapter 4. So we want you to get to know what the periodic table looks like, and here are the uses. And we're going to talk more about these in the next lecture.